Good morning everyone. Today I am going to tackle lecture of probability and statistics chapter number 1 basic probability. In our previous lecture we have already seen in the different types of the examples depends on the simple probability, conditional probability and Bayes theorem. So this is the next example depends on the basic probability. The question is two students X and Y work independently on a problem. Okay, the probability that X will solve it is 3 by 4 and the problem that Y probability that Y will solve it is 2 by 3. That means we have the two students and X and Y and work independently. Okay, on a problem. The probability that X will solve it is 3 by 4 and the probability of the solve by X will solve is 3 by 4 and the probability of Y will solve it is 2 by 3. So what is the probability that problem will be solved? Okay, so we have already seen in our previous lecture we have the three students and problem will be solved. So what is the probability for problem will be solved? So if one student can solve the problem, one student can solve the problem, then we can say that the problem will be solved. Okay, so here the solution is X will solve the problem. X will solve the problem Px. Okay, and Y will solve the problem. Y will solve the problem Py is equal to Px is equal to 3 by 4 and Py is equal to 2 by 3. Got it? So here the x and y are work independently. We are given in x and y work independently. So P x intersection y is equal to what? The formula of the P x intersection y is equal to P x into P y. Why? Because of x and y work independently. So we put here the value Px is equal to 3 by 4 and Py is equal to 2 by 3. Got it? So here 3 cancel and 2 2 are 4. That means 1 by 2. So probability of x intersection y is equal to 1 by 2. Okay, but the question is what? A question is what is the probability that problem will be solved? That means what? We find probability of x union y. Got it? So here the probability of x union y. We find this value. Okay. So we find the x intersection y is equal to 1 by 2 and px is equal to 3 by 4 and py is equal to 2 by 3. But we find the solution is the Px union y. Okay. So what is the formula of the probability of x union y? So the formula of the probability of x union y is equal to Px plus Py minus Px intersection y. Okay. So Px union y is equal to Px plus Py minus Px intersection y. So what is the value of the Px? Px is equal to 3 by 4. Py is equal to 2 by 3 minus x intersection y is equal to 1 by 2. Okay. So solve this all these values. So here 9 plus 8 divided by 12 minus 1 by 2. Okay, so 9 plus 3 3 are 9, 4 2 are 8. So 9 plus 8 into 4 3 are 12 minus 1 by 2. So we get the answer is 0.9167. Okay, so this is the value of the probability of x union y. Okay, so this example is very easy, depends on the basic probability, because of here one point is very important, and this point is what? Point is the independently. Okay, so always keep in mind, if your question depends on the basic probability, so first you read carefully, because of some clue is already included in your question. Okay, here the clue is what? Two students X and Y work independently. That means what? We are given in, if we use the probability of X intersection Y is equal to what? Px into Py. This is a very important point according to this question. Okay, and what is the probability that the problem will be solved? So if one student can solve the problem, then we can say that the problem will be solved. Okay, so we find the probability of X union Y. So what do you mean by the X union Y? Either X student or Y students. Okay, so here we find the value of X union Y. But for finding the X union Y, we have the value is Px 3 by 4, Py 2 by 3, and we are given in the X and Y work independently. Okay, so Px intersection Y is equal to what? Px into Py. So here put the value of Px into Py. So Px is 3 by 4, Py is 2 by 3 is equal to 1 by 2. And after that we write the formula X union Y is equal to Px plus Py minus Px intersection Y. Put all these values according to this formula and we get a final answer. The problem will be solved is 0.9167. Okay. So this is the second example for depends on the basic probability. 4 cards are drawn from a pack of cards. Okay, so we have already known that the total cards is 52. Total cards are 52. So 4 cards are drawn from a pack of cards. So total cards are 52. Find the probability that, and we randomly taken out the 4 cards. Okay, so first one is the all are diamonds. Okay, so you have already known that we have the 4 types of the cards. Number 1 diamonds, clubs, spades and hearts. Okay, so here and all these 4 the total counting is what? 13, 13, 13, 13. Okay, so here all are diamonds. That means what? We find the taken out the 4 cards. Okay, so here the total diamonds number of cards is what? Number of cards is 13 and we taken out the 4 cards. Okay, that means first we find the total possible outcomes. That means we can say that the total exhaustive event. Got it? So here first we find the all are diamonds. That means we taken out the 4 cards. So 4 cards are diamond. Second one is find the there is 1 card of each suit. That means don't be confused here. There is 1 card of each suit. That means what? We have the 4 type of the suits: clubs, diamonds, spades and hearts. Okay, and we randomly selected the 4 cards. Okay, so one is club, one is spades, one is diamonds and one is hearts. Okay, so here in the second one we find the probability there is 1 card of each suit. Got it? And third one is the there are 2 spades and 2 hearts. That means we selected total 4 cards, but we find the probability for getting 2 spades and 2 hearts. Okay, so the solution is that first we find the total possible outcomes, because of we have already seen in the first lecture, if we find the probability of any events. So what is the formula for finding the probability of any events? Formula is total favorable outcomes divided by the total possible outcomes, or we can say that the total exhaustive event. Got it? So here first we find that there are 52 cards. The solution is there are total 52 cards. Okay, total 52 cards, and we draw the 4 cards. Okay, 4 cards drawn. Then we write here the 52C4. This is your total possible outcomes. 52C4. Okay, and how we solve here 52C4? Here we write the factorial 52 factorial 4 and 52 minus 4. That means factorial 48. Got it? Factorial and LCR. So what is the formula of LCR? Factorial and factorial R, factorial n minus R. That means factorial 52, factorial 4 and factorial 52 minus 4. That means factorial 48. Okay. So here 52, 4 and 48. And after that you solve this term. So total possible outcomes is 52C4. Okay. So first we find number 1 is what? Number 1 is all are diamonds. Okay, all are diamonds. That means, for example, event is age. So what is the probability of age? So probability of A is equal to what? All are diamonds. That means we find here the 30. That means total favorable event is what? 13C4. Why we write here the 13C4? Because of the total diamond cards is 13. So 13C4 divided by the total possible outcome. So total possible outcome is what? 52C4. That means 13C4 divided by 52C4. After solving this term, we get the value of 0.0026. This is your final answer. That means the probability of all our diamonds is 0.0026. Okay, this is your first answer. Second one is what? Second one is there is one card of each suit. Okay, so that means each suit have the 13 cards total. So what is the second one? Second one is there is one card of each suit. Okay, that means each suit have the 13 cards. So 13C1 into 13C1 into 13C1 into 13C1. Okay, so why we write here the multiplication sign? Because of we have the total 4 cards. Okay, for example, we select the only one card. One card is spats or hearts or diamond or clubs, so we write the plus sign. But here we have the total 4 cards and all cards are each suit. Okay, so here we write the probability of B is equal to. So in the denominator we write here the 52C4 because of total possible outcome or total exhaustive event. Okay, and in the numerator we write here 13C1 into 13C1 into 13C1 into 13C1. Okay, so 13C1 into 13C1 into 13C1 into 13C1. So after solving this term, we find the value is 0.0002. Okay, and 13C1 that means what? We write here 13C1 that means factorial 13, factorial 1 and factorial 13 minus 1 that means factorial 12. Okay, so solve this step. So we write here 13 into factorial 12. Got it? Divided by 1 into factorial 12. So this is the cancel. So factorial 12, factorial 12. So we get only the 13. So here 13 into 13 into 13 into 13 divided by the 52C4. Okay, and after solving this term, we get the probability of all there is one card of each suit is 0.0002. Okay, third one is there are 2 spats and 2 hearts. Okay, so how we find the 2 spats and 2 hearts? So here the total number of spats is 13 and total hearts card is total number of is 13. So 13C2 into 13C2. This is the term is in your numerator form, and in the denominator we write the total possible outcomes or total exhaustive event, that means 52C4. Okay, so here the third one is there are two specs and two hearts. There are two specs and two hearts. Okay, so here we write the probability of C is equal to, in the denominator we write here the 52 C4, okay, but in the numerator we write here the 13C2 because our total specs is 30, so 13C2 into 13C2, total number of cards is 13C2. If you have any confusion, so first in the suffix form you sum all these sums, so 2 plus 2 that means 4, and we randomly selected the 4 cards. Okay, so after solving this term we get the answer is 0.0006. So this is the answer of the two specs and two hearts. That means the probability of getting two specs and the two hearts. So this example is very easy, but this example is very important because of here the 2 points is very important. First one is the pack of cards. So total cards is 52. You consider here. Okay. Next one is the word is suit, each suit. That means what? We have the 4 types. Okay, so clubs, spades, heart, and the diamond. So according to this, we solve all these 3 possibilities. Okay, so this is the example of the basic probability. So I will continue this topic in our next lecture. Thank you for watching this video.